Okay, if we're going to solve this half-life problem, then we need to set this up. We have not been given an equation, and so we're expected to know if we have something that obeys the law of exponential growth or decay. So I can use any letter I want. Since we're talking about a mass, I'm going to use m. So the mass after time t is equal to the starting amount times e to the power of k times t, where k is our growth or decay rate. Okay, so this amount here is how much we started with, and so that's our m naught. And so already I can refine this equation. So my mass after time t is equal to what I started with times e to the power of k times t. I don't have to worry about that. Now, what other information do we have? We're told that after 11 days, there's 233 milligrams left. And what that's saying is the amount after 11 days, so m evaluated at 11, the amount after 11 days is equal to 233 milligrams. But I have another way to get m evaluated at 11. I can use this formula. And so if I put t equal to 11, I get k times 11. And so I'm going to write that as 11k. Okay, so I have an expression for the amount after 11 days here, and I have an expression for the amount after 11 days here. These are equal to the same thing, so I'm going to put them equal to each other. Okay, now I've got a way to solve for k now. Get rid of the 345. So after cancellation, now that 233 over 345, if that's a horrible decimal, I'm going to leave it as a fraction. So let's see what we get. 233 divided by 345. It's a horrible fraction. So let me do math and enter, and it does not even simplify. Okay, so here's how I'm going to leave it. I'm going to leave it as 233 over 345 is equal to e to the 11k. So now to find k, I'm going to take logarithms of both sides. Since the base here is e, I'm going to take ln of both sides. And using rule 3 of logarithms, I'm going to have 11 times k times ln of e. But ln of e is just equal to 1, so I don't need that. And now to find k, I just divide both sides by 11. Okay, so I'll make some space. Okay, so I'm going to have, and I'll write it up here, k after I cancel is going to be equal to exactly ln of 233 divided by 345. And then all of that divided by 11. Now I'm going to take k to 5 decimal places. So I'm going to put this in my calculator. So ln of 233 divided by 345, close parenthesis, then divided by 11. Okay, so my K, and I expected it to be negative because it's a decay rate, 0.3568. Okay, so I've taken that to 5 decimal places. So I can make some space again. And I can come back here and now I can refine this, my equation is 304, e to the k, and I'm going to take this value for k and times t. So I no longer need this version. So this is my formula, and now I can find the half-life. So if I want to find the half-life, I put 1/2 over on this side, and I have equals, and then I copy this side, but I get rid of the starting amount. There's a couple of steps that gets to this point, but if you can remember for half-life, once you have the complete equation in t, which we do, you put half over here equals, and then you copy this side of the equation, but you leave out the 345 on the front. Okay, so I need to find out what t is. So again, it's something in the exponent. So I'm going to take ln of both sides. So I get ln of 1/2, which I can write as 0.5. And I'll use rule number 3 of logarithms and bring that out the front. Then times ln of e, but ln of e is just the number 1. And then to find my time that it takes for half of it to decay away, I just divide both sides by what t is multiplied by. So that will cancel, and I'll be left with that is my exact answer for t. But now we're supposed to say how many days that is, and we're going to round it to 1 decimal place. So ln of 0.5 divided by the negative of 0.03568. And so my half-life, if I take it to 1 decimal place, is approximately 19.4 days. Okay. So in WebWorks, if it doesn't tell you how much to round to, and you just take it to the nearest day, the nearest whole number, it'll probably tell you your answer's wrong. If it tells you your answer's wrong, keep rounding until you get to 3 or 4 decimal places. If it's still telling you wrong after 4 decimal places, you've probably made a mistake.